Sure, you ain't studying, are you? You're on Facebook, ain't
Hello, how are you guys doing tonight?
I'm fine.
Good. How are you?
I'm all right, a little tired.
Yeah, same.
So, do you all have the exam review opened up from the announcement?
Yes.
Yeah.
Excellent. So, you guys tell me what problem you'd like to see worked out, and that's what we'll do. Don't be shy.
Could we start with question 27?
Yes, we can.
Specifically, number 7, please.
This one?
Yes. So not a red jack. That would give me 50 over 52.
That's exactly it.
Okay, got it.
All right, well, that was easy. Are we done?
I have some more questions. I don't know if anybody else wants to throw anything out before.
Okay, wait a minute, let me find one.
All right, well, tell me a problem number and we'll go through it.
I would love to go over question 12, please.
Okay. It's one of those really long ones, huh?
Yeah.
Yeah. All right, so family has 2 children. So let's see, they can have a boy or a girl. So boy, girl. I'm just going to make kind of like a Punnett square. Didn't leave much room there. So they can have a boy, boy, a boy, girl, a girl, boy, which is different than boy, girl, or they can have a boy and a boy. So 4 items in the sample space. How many are in event E? Exactly 1 daughter. So it looks like here and here are
So
exactly 1
2.
daughter. So 2 out of 4. Event F is at least 1 daughter. So at least 1. So we're going to do those 2. Oh, I wrote that wrong, didn't I? That's a GG. Girl, girl, right there. So they could have boy, girl, boy, or girl, 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 sorry. So that's 3 out of 4. Has 2 daughters. That would be 1 out of 4. Okay, so then the probability of E,
That's good.
I'm actually giving the probabilities up here, aren't I? I'm just so used to doing probability here. So how many elements? There's 2, there's 3, there's 1. The probability of E is 2/4. Probability of F is 3/4. And probability of G is 1/4. Well, I did these in an interesting order. They're not alphabetical, are they? All right, so the odds of E. So if there's 2 ways that it can happen, we're just going to take the 4 and subtract the 2. That's how many ways it cannot happen. So 3 ways it can happen out of 4, so that leaves 1 more. Notice these 2 will always add up down here, 3 to 1. But these 2 will always add up to that denominator, to that sample space. And the odds of G would be 1 way that it can happen. And we do 4 minus 1. So there's 3 ways that it cannot happen.
Okay.
Did I do that too fast?
No, that all makes sense. I think on the key that you shared with me, the letters got a
Oh, I
little bit
might have.
mixed up. So I just wanted to make sure that I was, yeah. So that's good.
Yeah,
Thank you.
yeah. Mhm.
Can we do the one card, number 2?
Okay. Find the probability that the card drawn is above a jack. So we count the ace as high, so the ace is going to be over here. So above a jack, and that's right here. So we're going to have the queens, the kings, and the aces. And there's 4 of each. So 4 times 3, that's 12 out of 52 cards in the deck.
Oh. I find the probability that the card drawn is above a 10.
So that means we're going to include the jacks, the queens, the kings, and the aces. So jacks, queens, kings, and aces, and there's 4 of each of those. So that's 16
12, 16.
out of 52. That the card drawn is a face card. So our face cards are all right here. There's 3 by 4 of them. So that would be 12 out of 52.
Okay.
Okay.
Mm-hmm.
All right. Anyone have another question?
Can you go over number 21?
My
All
computer's
right.
So I went ahead and I made my table. I think the thing that I'm getting most confused about is what the denominator is in a problem. So,
Okay. All right. So to determine what effect the salespeople have on purchases, a department store polled 708 shoppers as to whether or not they made a purchase and whether or not they were pleased with their service. Of those who made a purchase, so we've got purchase, and happy is 164, and not happy is 130. Of those who made no purchase, so no purchase, 175 were happy, and 239 were not. Find the probability that a shopper who was happy with service made a purchase.
so my brain tells me to do 164 over the total of 708.
708,
Mm-hmm.
all of those. Sounds
But
reasonable.
referring to the key, it says 164 over 294.
Okay, so I just made that up for you, and I'm sure that there are mistakes in there.
Okay, that's no
Okay.
problem. I just wanted to make sure I was setting it up correctly.
Yeah, because it doesn't say given. It's when we see
Okay.
the word given that our sample space changes.
Okay, got it.
So let me just write that there. Given changes sample space.
So when it says given, that is the denominator. Like given 300, then we know that that's going to be on the bottom.
Exactly.
Okay, got it.
Okay. So then I probably have the wrong denominator on this one too, I'm thinking. So find the probability that a shopper who was unhappy with service had not made a purchase. So that's 239 over 708.
Okay. Okay, thank you.
All right, another question, y'all?
Can we do 24?
Sure.
Probably.
So use the spinner shown. It's equally probable that the pointer will land on any one of the regions. The pointer lands on a borderline, you spin again. The pointer is spun twice. Find the probability that it will land on green and then land on yellow. Okay, so we're going to do our first spin and we're going to do our second spin. So the probability that it's going to land on green and then on yellow. So green, we've got a 1 out of 6 chance. And then yellow, we also have a 1 out of 6 chance. And so because all of the combinations here can be matched up with all the combinations here, we multiply this and we get 1 out of 36.
Okay. 1
Did
out
you
of 36.
Okay,
I'm sorry, while we're on this page, can you do 25, please?
25, yeah. Okay, consider a political discussion group of 5 Democrats, 9 Republicans,
25.
6 independents. Suppose that 2 group members are randomly selected in succession to attend a political convention. Find the probability of selecting 2 independents. All right, so in probability, we need to know the total. Up here, our total was 6 because there were 6 things there. Here, if we add these together, this is 15 plus 5, we have 20 altogether. So we're going to select an independent, and there are 6 independents. So that's a 6 out of 20 chance for our first pick. And then we're going to pick another independent. So we've already picked one. Up here, when I spun and got it green, that did not affect at all spinning again and getting a yellow. Down here, though, on my next one, I'm going to have 1 less person. So I'm going to have 19 on the denominator. And I no longer have 6 independents to choose from. I only have 5 to choose from.
Oh, okay.
So 6 times 5 is 30. 19 times 20, 19 doubled. 380. Does that make sense?
Yes, thank you.
Okay, good. All right, next question. What should we do next?
Let me find one.
No more questions? Well, this was a quick review.
I have a question. Hi, Professor.
Yeah. Hi.
Will you please just go over number 8B?
Okay, let me find it. And I'll be happy to. What are the odds? Oh, let's do probability first. So a pair of fair dice are rolled. So that chart is going to be on the test, or on the formula sheet. So you'll have that two dice sums chart. So to get a 10, we'd have a 4 and a 6, or we could have a 6 and a 4. So you're not going to have to do this on the test. And then we could have a 5 and a 5. And I think that's all of our combinations for a 10. Okay, so the probability of rolling a sum of 10, there's 3 of them here. And if we do the whole chart, it's 6 by 6. So there's 36 total things. We only have 3 of them here. So it'd be 3 out of 36 for the probability. So now if we have the probability, that helps us figure out the odds, because the probability is going to be 3 to 36 minus 3. So it's 3 to 33. None of these are 3 to 33. Oh, but this is saying against. I'm doing the 4. Oops, sorry. This is 4. Question is asking against. This is where I would be lucky that I have the retake on the questions and I would see that, oh, I did the 4. Got to do the against. All right, so the ways, it's just going to be opposite of this here. If this was 3 to 33, then this one is 33 to 3, which simplifies to 11 to 1.
Oh, that makes sense. Okay, thank you, Professor.
All right, what question is next, y'all?
30 and 31.
31.
All
Oh,
of them, really.
fun. Thank you. These are the fun ones, aren't they? Okay. So Casey's taking 2 courses, German and Econ. Passing German, so passing German is 0.2. Failing Econ is 0.7. Passing at least 1 is 0.4. Okay, so so the easy one here is the passing econ. So we know if failing econ is 0.7, to pass, it would be 1 minus 0.7 or 0.3. Okay, so now we know passing econ is 0.03. We know passing German is 0.02. So where should we go from here? So I know passing one, I know passing the other. And then at least one, at least one. Let's do this. Remember the probability of A plus the probability of B. minus the probability of A or B. This is A or B. So the probability of the A, I'm saying is pass. So that's 0.2 plus B, I'm saying is the fail, is 0.3 minus the probability of A or B, which is the 0.4. So 0.2 plus 0.3 minus 0.4 equals 0.1. So maybe, I don't know, do some of you do these with the Venn diagram?
I'm not that good at the Venn diagrams.
Yeah.
You could do a Venn diagram for us though, because that.
Okay. So let's see, this is German, and we'll make this one econ. And this is going to be, let's do passing. This is passing German, passing econ. So we know that passing both courses is 0.1. We know that passing German is 0.2. But I already have 0.1 here, so I need to get rid of that 0.1. So passing German only is 0.1. And then we have here, we've got passing econ is 0.3, but we have that 0.1 already in the middle. So we have to do the 0.3 minus the 0.1. So that would be 0.2. So if I add these together, that gives me a total of 0.4. This whole thing has to total 1 whole. So if this is 1.1 plus 0.1 plus 0.2 of 0.4, that means this is 1 minus 0.4 or 0.6. This is not a good class to take, people. Look at that. 60% of the people are going to fail. Oh, and that's the next question here. So 0.6 are going to fail.
Oh my God.
Yeah, that's an awful course. Don't take that, teacher. All right. So passing exactly 1. So exactly 1 is the German only and the econ only. So 0.1 plus 0.2. And we get 0.3. How did that feel? That one okay?
If we weren't to use the Venn diagram for C,
Mm-hmm.
how would that look?
So we know the passing of, I would just do a lot of subtracting here. So we know the whole thing has to total 1. You know, I would have to do the Venn diagram here because of this is going to give me that 0.1 and the 0.2.
I guess the part where I get caught up at is the number of steps for each
Mm-hmm.
question. I just can't drill those in my brain to remember how to do which one goes with which.
Yeah, and they're all different, so I can't just say if it's this, do that. So let's look at the next problem. Let's do this defective bulb thing. Of all flashlights in a large shipment, 19% have a defective bulb. 16% defective battery. And 10% have both. So given this defect, and that 10% have both, I can go right to this formula here. Because if I have one and the other, and then the both, which is the or, because it's this or that, or the other. No, this is the or. Sorry, this is the or, and we're looking for the and. So we're going to have probability of defective bulb plus probability of defective battery. I'm running out of room here. Minus the probability of both. The probability of defective is 0.19 plus 0.16 minus 0.1.
That's on that paper.
16. Bulb, 16 effective battery. You know what? I just have to go to the Venn diagram. Well, no, we're not doing the Venn diagram. So 16 and 19, 6 plus 0.19, brain's going a little crazy, 0.35 minus 0.1 will be 0.25 for a defective bulb or battery. Or bulb and battery, both. So good bulb or a good battery. So this is 1 minus the both defects. And the both defects is that 0.1. And then we have a good bulb and a good battery. So if, I'm sorry, I'm going to do a Venn diagram just to kind of show us here. So the both is the 0.9 in the middle. Yep. I don't know what.
I think you're gonna lose us or lose me at least. So what were
Yeah.
we titling? Is it we got
Okay.
a bulb and the battery for the two circles for the Venn diagram?
So 1 minus the defective bulb, which is 0.9, minus the both, which is, no, we didn't do the Venn diagram. I'm trying to do it without the Venn diagram and I'm having problems with doing it without. So
Would you suggest that we do it with the Venn diagram?
I think it helps. Let me see if I can find a
'Cause
pen
I'm not
here.
that good at the Venn diagram.
Okay. Okay, so the both defects is 0.1. So that goes in the middle. It's got both. Then defective bulb, defective battery, so defective bulb or defective battery. Good bulb. Oh, see, I'm going one way and then the other. Good bulb, good battery, defective bulb. Maybe I need to go the good way. So 0.1, 0. Okay, so the battery has to total 16%. We already have 0.1 here. So this is 0.06. The defective bulb has to total 0.19. We've already got the 0.1 there. So this is 0.09. Have I lost you all there?
Mhm.
No, makes sense.
Okay, so then the outside, this would be 1 minus 0.09 minus 0.1 minus 0.06. So the whole thing is 1 minus the 0.09, 0.1, 0.06. And that is 0.75. So 1 minus the defective bulb, 0.09 minus both, 0.06 minus the defective battery only. That's what I'm missing there is the word only. So 0.09 minus 0.06, that gives me that 0.75. Okay, it sounds like someone's crying. I don't mean to make you cry. I know you're actually just sniffling.
It's my allergies. I'm sleepy
I'm
too.
sorry. If you can, just always remember the formulas. if the formulas don't work for you, then do the Venn diagram. But the formulas are just like what we did in the last unit.
I was gonna say, you can't hardly, so what's the formula clear? Because I can barely read what you have.
So the number of elements in A, no, not number of elements, the probability of A plus the probability of B minus the probability of A intersect B equals probability of A union B.
Oh my God.
And then we just switch it around a little. Now, instead of doing the intersection there, we're going to do the union there equals the opposite there.
I think I just got cut off. God. Okay, here we go. Hopefully it won't shut down.
I think what I'm struggling with is when we start to do the complement of them, like a good bulb and a good battery. So we have to find like the 1 minus.
Yeah, because this one had defective, and then we all of a sudden
Mhm.
went to good.
That's where my brain just frizzles out a little bit. I'm trying to look and see if there's another question with that kind of setup in here.
Could you, sorry to interrupt, clarify. So if good bulb or good battery, wouldn't that be good bulb union, good battery? So wouldn't that be the 0.75 since that's the what's outside of the bad bulb or defective bulb and defective battery?
I'm sorry, where did points? Oh, there we go. That answer right here.
Mm-hmm. Would that not be under B since that's the union of both the goods and we just have inside the Venn diagram circle is the defective ones? Because the total defective is 0.25.
But this one is 0.9. The and has to be less. The and is the intersection. And the or is this one or that one or both. So the or is always going to be the larger one. The and will always be the smaller one because that's the intersection.
Professor, I'm sorry. What is the answer to C?
To B,
C as in cat?
oh, that's the 0.75.
0.75.
And can you show me the formula again? My computer was going
Show
down.
you the what again?
The formula that you were giving me earlier.
This?
Yes, because
Okay.
my computer was going down, so I had to get down here and plug it up to something.
Okay.
Okay, thank you.
Mm-hmm.
Okay, thank you.
So let me just go over it this way then. 0.19 is the defective battery. 0.16 is the defective bulb. I forgot the L. And 0.1 is both. So you can just go to the formula. And even if you don't know the and or the or, if you know that you have the two things here, you're going to add those two together and you're going to subtract the other number.
Okay. My paper's got all confused. Can we do number 14?
Okay,
My paper's all
let's look at number 14.
I mean, not, where's that 14? Yes.
Okay, so now this is the key thing on these problems. You want to look if you see the word given.
Mhm.
Anytime you see the word given, it changes your sample space.
And the sample spaces.
So the sample space here is 112,
Oh, okay.
but now this is telling us that our sample space is that the meal was lunch. So if the meal is lunch, our denominator is 65. So this given tells me that the meal is lunch. I'm only looking at the lunches, so that's 65. And then the service was poor. So lunch service was poor, 18 out of 65.
So we don't necessarily have to answer find the probability that the service was poor given the meal was lunch. That's just giving us information.
The question is written here twice, basically.
Okay.
Professor, could we do number 7 and 16, please?
Okay, you're going to have to remind me about the second one there, but let's start with number 7. Okay. Number 7, we have a jar on our desk with some jelly beans in it.
Number 7.
Okay, odds. Oh, all right. Odds in favor versus odds against. Okay, so there's fancy formulas for all these things. Odds in favor is just the number of ways it can happen. To the number of ways it cannot happen. So number of ways the event can happen, number of ways the event cannot happen. And odds against are just that switch. Odds against, so the number of ways it cannot happen. To number of ways it can happen. And this is all odds is. When you add up these two numbers, it's going to total your whole sample space. So if we have 13 black, 5 red, 10 yellow, and 3 green jelly beans. So we have a total of 13 plus 5 plus 10 plus 3 jelly beans. We have odds in favor, but we don't really even need a total, do we? So why am I doing that? You pick a jelly bean without looking. The odds in favor of picking a black. So how many black jelly beans are there? There's 13. Oh, it would help to know the total here, wouldn't it?
I think.
So what, 26 plus 5 would give us 31 for the total? So there's 13 ways it can happen to 18 ways it cannot happen. And then the odds against are just backwards, just like this. Odds in favor, odds against, it's just backwards. So it's 18 to 13. Number of ways it can, number of ways it can't. Number of
So you
ways
just picked out the odds, or you picked out the black jelly beans first.
Because this one's asking about the black. So there's 13 of those, and there's 18 of them that are not.
Okay, simple. And then it's just the opposite for the odds.
Against, yeah.
Okay.
All right, what was the other problem number?
Number 16.
16?
Yes.
Oh, don't make this one hard. Oh, okay. It's got a whole bunch of junk here. Makes it look confusing. All right, a student is taking part in a lottery for a room in one of the new dormitories at the new college. He is guaranteed a space, but will have to draw a card randomly to determine which room he will have. Each card has the name of the dormitory, X, Y, or Z, and has a 2-person room number or apartment number. So room or apartment. Okay. I'm not even going to worry about this yet. So this is asking for the probability of a room. That line right there means given that they are choosing X. So since we're choosing X, we're not worried about anything else right here. Because it's given X, we're only looking at the X's. So D, oh, we don't even need to do that. Room given its X. Room given its X. So D is 0.80. That's our answer. Or just 0.8.
Oh, so you just looked at room, and then D is the first letter you seen, and you go down on the diagram list and choose D as 0.80.
Right, because D is the room.
So essentially for these problems, we just have to read it thoroughly and carefully because it might just be a simple answer.
Because it was
Yes.
making me think I had to do a lot more.
Nope. Yeah, it does make it look like you're going to have to do a lot. Like, oh my gosh, I have to label all of these things. What is it? And then if you're doing it on the computer, you're thinking, oh, I got to draw it out on my paper. But no, because it's telling you given X.
Okay,
That
thank
line
you.
is the given.
This line means given.
It's telling you your sample space.
Okay.
So we're only looking at the X's, nothing else.
So,
All right, anyone else got another question for us? Or anyone?
Will
I
you
do.
go over? Oh, you can go ahead.
Professor, will you please just go over number 9 and 10? Just because I want to see. Thank you.
Okay. Yeah, these are good ones to talk about. I don't know that they're on the test or not. I try not to look at the test right before I do these reviews so that I don't know what questions are on the test. But okay, so probability is the number of ways event can happen. Over total sample space. So there are 3 ways this event can happen and 6 ways this event cannot happen. I'm sorry, no. There are 3, sorry, there's 3 ways this event can happen out of 6 items. I was getting ahead of myself here. So that means the odds, we're going to keep that 3. There's 3 ways the event can happen, and odds are the way it can to the way it cannot. It can happen 3 ways, and it cannot happen our sample space minus that 3. So this is 3 to 3. If the probability is 8 to 13, then the odds of E are 8 to 13 minus 8, or 8 to 5. Now it's asking for the E complement. So it's asking for not E, which would just be the opposite of E. So instead of 8 to 5, it's 5 to 8. Okay, we're getting this now. So the probability is 2 to 7. The odds is 2 to 7 minus 2, which would be 2 to 5. All right, now this one's a little bit trickier. This one is telling us the odds is 6 to 6. So our top number has always stayed the same. So it's going to be 6 out of, and then it's just the total of these two. So 6 out of 12. Okay, any questions on either of those?
Thank you so much, Professor. Makes sense. Thank you. Thank you.
Good.
Will you go over question 17, please?
Sure. Since you said please, yes, we will. Okay, so this line means given. Given changes the sample space. So given tells us what our sample space is. So here our sample space is Y. So we're only looking at the yeses. So our total sample space is 407. We're going to probability. So 407. So from the given Y, how many of those are males? And that would be 125. Does that make sense how I just did that?
Yes,
I hope.
thank you.
Okay. All right. So now 2 is telling us that we're using the W's. So that would be women. So our denominator is the women, 382. And of those women, how many of them said no? And that would be 70. All right, now we just have an intersection. So where does N intersect W? N intersect W is 70. This one doesn't have any given. It doesn't have that line for given. So that means our sample space is out of the whole shebang, 615.
So we're still talking about women, right? So N is 70.
We're
And then-
talking about all of them,
Okay.
and where N intersects W is 70.
Okay.
N intersect W.
And then we got the 600 and is that 615?
15.
Okay.
All right, so now this one is telling us our sample space is just the ends, because it's /n, so just the no's. So our denominator is the total of the no's. And then how many women said no? And that would be 70. Probability of just women. There's 382 women out of 615 altogether. This one doesn't have that line in it that changes our sample space. And same thing here. This one doesn't have the line in it, so it doesn't change our sample space. We're just looking at the total number of no's out of everyone altogether.
That's making a lot more sense. Thank you.
It is.
All right. Should we just stick on this one and do this one right here then?
Please.
All right, we see the word given, so I know given is changing my sample space. Given changes the sample space. We have 340 males, 260 females, so 340 males, 260 females, 220 of the men, 220 of the men, and 160 of the women are on flex time. Given that the employee selected at random from this group is on flex time, so since they're on flex time, we don't care about the total. We just care about the ones who are on flex time. Because given that they're on flex time, what's the probability that the employee is a woman? So that is 160 out of just the
260.
women. So 260. This is flex and woman. And this is just the women. Oops, did I do that backwards?
Oh,
No, no, no. 260 female employees. 160 over 260 is correct. This is, oh, I did have that written down right. Women on flex time. And then this is total woman. I had second guessing myself. I'm sorry, I shouldn't be doing that. Flex and women.
I was getting
Wait a minute.
220 plus 160
Yeah,
is
wait a minute.
380.
On flex time, I'm so thinking woman right now. Thinking woman, hear me roar. But that's not what it's asking, is it? It's on flex time. So our sample space is flex time.
okay.
Sample space is flex time, and 160 plus 220. So 220 men and 160 women. So for a total of 380. So this is our sample space. This, given that the employee selected at random is on flex. So this is our given, which equals our sample space. So that's the denominator. Okay, so now what's the probability that the employee is a woman? We have 260 women. So 260 over 380. Make more sense?
Is it not one? It's 160, right? Because those are the women that are on flex time, 160.
Oh, yeah, 160 of the women are flex time.
That is a 1. What are you talking about?
Yeah, I had to put my glasses on. Sorry.
And I'm gonna have another swig of soda here. Caffeine. Good stuff. I had a very long day today because I had to write someone up for academic, for cheating on the last test. And I did not like doing it. But it was just so flagrant and obvious. And I'm just all frazzled from it yet. Sorry. Okay, sorry. Blah, blah, blah. What are we doing next? What question next?
Can we do 44? I had a question about the problem in general. I understand the method.
What number was that? 44?
Yes, 44. There's a few of these on this sheet.
Mm-hmm.
But we can go over it for those, for everyone, but my question to you was when I put it into the do I when I'm calculating it, do I do my probability first, or do I do the number of first?
It doesn't matter because you're multiplying these.
Okay, I got you.
So we multiplied in parentheses the 0 multiplied by the 0.1.
Plus 1 times
0.
3. Order of operations, it's just going to do the multiplication stuff first, and then it'll do the adding stuff. So I'm pretty sure the Desmos calculator, but if you want to be safe, you can put the parentheses around it, but it should be okay without the parentheses in the Desmos.
And then
And you just do that whole thing, and I just happen to have the answer right here worked out. It's 2.35.
And then I'm going to throw in 46 as well.
Okay.
Thank you.
All right. So your home insurance company estimates that a certain home has a 2.8% chance of burning. They calculate it would cost 140,000 to rebuild the home. Use expected values to determine the annual insurance premium. Okay. Well, we know 2.8% of the time it's going to cost $140,000. So that is 0.028, just changing that percent to a decimal. So this is the positive. So well, except for in this kind of thing, but in real world kind of odds, you're going to have a positive and you're always going to have a negative. In this case, though, it'd be 98. I shouldn't even be writing this down. I'm just confusing you with this. I'm not even going to write it. Let's just leave it as this. So 0.028 times 140,000 is just going to be 3,920. Okay.
yes,
What question next? We're done? Are you all thinking right now, I cheated on the last test. I know she's talking about me. That's what you're all thinking, right? And I'm just kidding right now. It's none of you. Don't worry.
I don't know how they would manage to cheat anyway. You had the cameras on them all the time.
Yeah, so that's why they were caught. Yeah.
I have a quick test taking question. For my brain, it's easier sometimes to use different colored pens. Is that a problem?
I'm sorry, what? You faded out at the end.
Is it okay to use different colored pens, like
Oh my
multiple writing
gosh,
utensils during the
yes.
test? Okay.
Yeah, I mean,
fabulous.
I don't know if you
Okay.
saw, but I started off with a bunch of different colors here. And
That's
now
how my
I've got,
desk has been looking, and it's just more helpful. Okay,
oh,
thank you.
I totally get that. Yeah. Have a bunch of pens out there.
I got one more if we could squeeze that in.
Okay.
50.
50? Okay. Should
Thank you
they
so much.
settle out of court or not? Okay. So company, okay, so there's,
So after you do 50, can we do 22?
okay. Did anyone want to see number 50?
I do.
Wait, yes, we're doing number 50 or no, we're not doing 50?
Yes, we're doing 50.
Okay, I'm getting so confused here. Okay. In a product liability case, a company can settle out of court for 200,000. They go to court and they lose, they're going to lose 200. Ooh. 2,500,000. Ooh, that's not good. If found guilty, and nothing if found not guilty. There's the not guilty is 0.77. So then guilty is 1 minus 0.77. So we're going to take the probability of guilty times the loss. Sorry, times the probability. So probability of guilty is 1 minus 0.77. And the probability of the loss is an awful lot of money. If we did the not guilty, well, the not guilty would just be 0, the opposite of that, times, we don't need to do that. I'm confusing you all again, I'm sorry. Just do that. So we just plug this into the calculator and we'll get $575,000. So the two things are not equivalent, but I'd rather pay $575,000 than $2,500,000 if you go to court and lose. So yes, they should settle out of court and just pay the 200,000 rather than possibly 575,000. Okay, what number is next?
This number 22.
So this is just kind of our straight up probability here. The shopper, so we know our total is 501. The shopper did not make a purchase. So made a purchase, did not make a purchase would be 272 out of the total 501. The shopper made a purchase. So made a purchase, 107 out of the 501. The shopper made a purchase and was happy. So we want to find purchase and happy where they intersect. So 107 out of the total. Happy with the service they received. So that's 214 out of 501. Shopper made a purchase or was happy with service. Okay, so made a purchase is 229. Or was happy with service. Happy with service is 214. But then we have to take away the made a purchase and happy because we counted this 107 2 times. When we went down, we counted the 107. And when we went across, we counted that 107. So we're adding those two, subtracting out the 107, and all of that's over 501. And we do that.
And we subtracted the 107 because we already used it twice.
Yes.
Okay.
So this is 336 out of 501. Okay, so the shopper did not make a purchase, that's 272. Or was unhappy. Not happy is 287. But there are people who did not make a purchase and were unhappy. You don't want to count that not make a purchase and were unhappy twice, because we counted it going across and down. So we're going to minus out that 165.
So the shopper made no purchase was 272. The shopper made no purchase was 272.
Plus the happy with service. And then we subtract out the one that got added twice. The 165 was included in the 272. And it was included in the 287. So we have to get rid of it once. Because
Okay.
we counted it twice. And
So it's 272 plus 122.
Plus 287.
Oh, you do, okay. And you're gonna subtract.
165.
Thank you.
And that's 394 out of 501.
Okay.
Sorry, Ms. Collins, you asked what was the total number of who did not make a purchase? Is that what your first question was? I just want to make sure we're not confused.
On the last part, I said the shopper, no purchase.
No purchase was 272.
Yes, that's what I have. Thank you.
Sorry.
All right. What's coming up next?
Maybe 23.
Okay.
Maybe right under it.
College administration has conducted a survey of 178 randomly selected students to determine the relationship between satisfaction with academic advisement and academic success. They obtained the following information. Of the 67 students on academic probation, so 67 are on academic probation. 27 are not satisfied. However, only 20 of the students not on academic probation are dissatisfied. What is the probability that a student is not on academic probation and is not satisfied with advisement? All right. So we know 67 are on it. We know that we have a total of 178. So 67 are on academic probation. That means 178 minus 67, or 111, are not on academic probation. And we know what is this 20 again? 20 of the students on academic are, oh, this is not on academic probation and dissatisfied. So our bottom number, probability that a student is not on academic probation, so that's this number. That's our denominator. And then the numerator is those 20 of the students not on academic probation or dissatisfied. So 20 out of 111. Do we have another question?
So we don't have to simplify that. That's, or it can't be simplified. I'm sorry.
Right. I don't think you have to simplify any of them.
Okay.
Professor, will you please go over number 26?
Yes.
Thank you.
Mhm.
6. That's good. Okay.
So I have a spinner, 10 equally sized sections, 4 of which are green, 6 are red. I'm not even going to attempt to draw the spinner, but we know 4 are green and 6 are red, and they're all equally spaced, so that makes up that 10. The spinner is spun, and at the same time, a fair coin is tossed. What's the probability that the spinner lands on green and the coin shows heads? So we're going to do the probability of green times the probability of showing a head. So probability of green is 4 out of 10. The probability of a head on a fair coin is 1/2. So this would be 4/20. Or 1/5.
Thank you.
You're welcome. All right, how we doing, gang?
Sleepy. Can we do 37?
Okay.
I'm so sleepy.
And a class of 57 students.
Oh, wait a minute. What's that? 37?
Oh, I thought you said, oh, I'm sorry, I misheard. 37?
Yes.
Okay. A single die is rolled. Find the probability of rolling a 6. So 1 out of 6 chance of rolling a 6. All right, now here is that word given. That given tells me the denominator. Given that the number rolled is even, that's 2, 4, or 6, so I know there's only 3 options there. Given that the number rolled is odd, I know there's only 3 odds, 1, 3, 5, so there's only 3 things. Given that the number rolled was a 6, there's only 1 6, so the denominator is 1. That given tells you that denominator.
Okay.
All right, so now here, given that the number rolled is even, so that would be the 2, the 4, and the 6. How many of those are 6? And it's just 1 of the 3. Given that the number rolled is odd, so that would be 1, 3, and 9. Find the probability of rolling a 6 given that the number rolled is odd. Well, that's not going to happen. Given that the number rolled was a 6, find the probability of an even number. Well, 6 is an even number. So 1 out of 1.
Oh, okay. Thank you.
Mm-hmm.
I'm sorry. For C, where did you get the 9 from?
I have no idea where I got the 9 from. How about a 5?
Okay, you giving me anxiety now, okay?
Sorry.
But the answer is still 0 out of 3.
Yes. Yes. Thank you.
Sam's guess is wrong, but the answer is right.
Exactly. That's all that mattered. All right. We're going on an hour and a half, people. How we doing? All right, everyone just got quiet. What's wrong?
Awesome.
Doing all right?
Yeah.
Okay.
Professor, do you know how many questions is on this test?
Hold on, I can, oh, you know what? The simulated exam reviews have about the same amount of questions that are on the test. But I am looking it up right now. It's gonna take me a minute to get in there.
So we'll do the review first and then take the.
That's a good idea to do that.
And do we get graded on the optional probability exam comprehensive?
No, you don't. But the research shows that those who do those simulated exam reviews do better on the exam.
Okay.
All right, the probability exam has 12 questions on it, but one of them is that last one that tells you to turn in your scratch paper.
Okay.
So it's 11 math questions.
Okay. Thank you.
Mhm.
Oh, turn it in my scratch paper. So that means I have to take a picture of it.
Yes.
And I guess take a picture of it with my phone. And
Mhm.
then,
Exactly.
okay, I'll
I
figure
will-
out.
I will, just so you know, I take a picture with my phone, I email it to myself, and when I email it to myself, it saves itself as not a JPEG, or what's required for it to submit. So just make sure you look at it, and if it's not saved as that, open it up, click Save As, and then make sure that when you do Save As, the option is that it's a JPEG, or I don't remember the other one.
They're both like JPEG. One is JPEG, and then the other one is JPG.
And then that should load it right up to the site we're already on.
Once it's saved
You're
as
doing that in Canvas. You're not doing that in the exam.
Okay. So we're just taking a picture, uploading it
Yes.
after the exam or before while we're in the exam?
within 10 minutes.
After, yeah.
After. Okay.
Okay.
Yes.
How are you all feeling about this test, gang?
I mean, going over it does help. I do need a little bit of time to practice. So that's what this optional probability exam comprehensive review will do, help me remember,
Exactly.
practice. Okay.
Yes.
Professor, do you have any recommendations for people who get extremely anxious? Because that's one of my biggest problems. As we're going through the review, it seems like I know what I'm doing, but once I'm there, I freak out and I just get overwhelmed.
Yeah, me too. But going over it like this is almost better than, I mean, I know that we have all the videos and stuff, but sometimes it can be confusing.
Mm-hmm.
I want to share something. So I did 3 of the test simulations for the last exam.
Yes.
And I literally did the first one, and I'll tell you guys, I got like 70 something. And then the second one, I got 80 something. And then on the exam, I got 90%. But that's because I literally took this test simulation right before I took the exam. And for some reason, it helped put me in a mindset and it calmed me down as I was taking the real exam. So I don't know if that will help you guys, but yeah, I did the simulation right before I did the exam, so for me it helped.
So that's what I'm
Excellent.
gonna do.
Good.
Because I just blank right out when it's time to, and I think about the camera, and then I'm out.
Yeah.
Yeah, that's how I did my practice too. I did them before and then I took the exam. But I think towards the end where I was actually taking the exam, I started overthinking and it didn't. I mean, I didn't do as bad as I thought I was gonna do, but I didn't get the grade I wanted either.
Just don't literally, but like figuratively, take a step back, take a deep breath. Just take some deep breaths and relax. Know that you got this. And you
Well, I do
will.
feel better with us going over it like this.
Good.
Yeah.
Yeah, I appreciate you going through all of our questions.
Are you guys reading what Devin wrote there?
Where?
Oh, in the chat. Studies have shown that you should take your exam in the same state that you are studying. Take note of yourself during studying and mimic it for the exam.
I don't know. Because when I'm working, sometimes I have paper everywhere because I'm trying to figure out how to solve the problem.
I'll step in. I did type that in. I have high test anxiety, so I tend to try to just figure out like so like a kava drink, like a calming and relaxing drink is usually what I take to kind of just like stop myself from getting over anxious. And it helps out for me.
Okay.
So also like maybe you might perhaps try to figure out a different, obviously schedule permitting, we're all working, but find a different study environment that may be more beneficial to you when it comes to this, especially if this is, I mean, this is a minimum requirement to make sure we get our degrees. So if you could find the time to just put yourself, I lock myself in my room for hours at the end of my day because that's how important this is to me right now. So I'll spend 8 hours after I go to work sitting in a room.
Yeah.
Yep, same here. I do it after work. I honestly, professor and everybody, I mean, I remember crying on my first week.
Yes, me too.
Oh,
I cried, but you know what? I got it out of my system and it was okay. And plus, I remember professors said that um the chances of getting at least a good grade, overall good grade in this class is as long as we do the all of the assignments, all of the learning opportunities, and get at least a 90 to 100% on all of them, it will even out, right? With
yes.
versus the exam. Yeah, yeah.
Mm-hmm. Yes.
Yeah, but sometimes I struggle trying to get the homework just completed because it's so much.
I hear you on that.
Yeah, 'cause, by the time I get home, I'm working. And then when I get in here, I think I got one assignment. Then I look again, it's another assignment right under that.
Sometimes there are two. Yeah. You guys actually have less work than those who are in person.
Really?
Yeah, those who are in person have 3 of those written problems. You guys only have 1 per unit. They have 3 per unit.
I'm struggling with the 2 assignments right up back to back because
Yeah.
I think
And
for
they
me,
have more practice assignments too. You guys don't have as many practice assignments as they do.
yeah, for me, it's more than anything that we have a homework assignment due every day. Whereas
Yeah.
courses, it was these are the amount of assignments you have to do, turn them in by Sunday.
Mhm.
And since I have 2 jobs back to back, I come home like extremely tired. So it's just trying to keep up on a daily, day-to-day basis
Mhm.
and finding that balance and finding the time to just study and sit down and not get overwhelmed with everything else going on. But I'm trying, I'm doing better than what I thought, but I'm still
That's good.
aiming higher.
Mhm. But you're doing this just for a couple more weeks.
Mhm.
It's like
And
4
then-
more weeks. I counted
Mhm.
Yeah.
using the probability method. I work nights, so it's hard for me. Just period, and then I have a different time zone, so it's like
Mhm.
I think I have an extra 2 hours more than the Arizona time, but in reality, it's not. And then I get confused by the dates because like my test says it's due on the 5th at 2 in the morning, but in reality,
That's midnight Arizona time.
yeah. So I get confused with my dates because it'll have me thinking it's not due to the next day.
Mhm. But your brain is getting trained now.
Yeah.
I hope so.
Just don't forget you have that ASU clock on the left side of your Canvas
Yes.
app to help yourself figure out where you're at. Because I have the same thing. I'm 2 hours ahead, and
Yeah, me too. I'm 3 hours.
if I look at my phone, it's like, oh, it's due on this date. I'm like, oh crap. Oh, wait. So
Yeah, I was struggling with the Arizona time.
this week I've tried to get ahead of myself. So like at least trying to be one day ahead.
Yeah, if we're not one day
That's a
ahead,
good plan.
it's not gonna
Yes, it's
not gonna work.
huh? Well, I think one day ahead would help us a lot, but it feels like a lot. So one day ahead, I need to try and get there.
Yeah, like over the weekend, we don't have work. So
Right.
that's when I try to catch up. If I'm not already one day ahead, then
Mhm.
I try to at least have Monday's work done by Saturday, Sunday night, so that it starts me off the week ahead.
That's a good plan.
That is a good plan. I need to pick that up because I struggled through the week.
Yeah, I started it.
Just getting it all done. I'm thinking I'm going day by day, but when you get closer to the end, it's more assignments.
And that puts pressure on you if you do it
Yeah.
day by day.
Yeah, and I like the fact that it's the interactive videos at the bottom of the
Good.
problems.
Mm-hmm.
That's the only way that I'm able to make it through. Like I listen to the lecture, but she's very brief.
Mm-hmm.
But once I dive into the work, I see that every single problem has it has a printout of a step-by-step walkthrough typed out, and then it also has a video attached.
Mm-hmm.
So that's kind of like the best way that I can, without talking in a Zoom group, that's the best way. But I also, if I'm stuck on something, I go straight to the tutoring center and I'll just sit and wait until someone can help me. And more than likely, it's someone that can do our work because we're not that far ahead and like we're not in any hard math classes yet.
Right.
Luckily, this is my only math class I need for my degree, and I'm grateful when in our 4 weeks, I'm just going to be grateful to have this experience done with.
Yeah, the tutoring session was really nice the other night that I got on. They were really helpful. I need
Good.
more. You don't have a certain amount of time though, so I have to call and get more time.
I gotta say though, after tomorrow's exam, the next one is not till the 14th. So we have a week off.
With the tutoring, if you do it live, more than likely they have someone, you don't have to schedule an appointment with them. If you do a live tutoring, they have people there that can jump on it and help you at that moment.
How do I just go right to their site I was on?
Yeah, and pick the live option rather than the scheduling.
Okay.
I had trouble with the scheduling, so I appreciate you letting us know that.
Yeah, that's
my go-to because we can't bug our professor at certain times, but they close, but they even have after hours too. And
Yep.
even though we have the group, on our group chats and stuff, someone's not always able to reach out at that moment to get you through that assignment, and it might be due,
Yeah. Mm-hmm.
So I just go straight to the live tutoring and I just navigate it through the page. Just look at everything. And it's a Zoom room. And once you get in there, they can help you set up so you can get on their waiting list. And the longest I've waited was like 5 minutes for someone to help me.
When I was on, it was really,
Good night,
I didn't have to wait long. It was really not, it was really nice and the people were really helpful.
But good luck, everyone. I'm going to call it a night. I appreciate this group and thank you, Professor.
Yeah, thank you, Professor. I gotta say, exam is much I find like this module at least is a lot easier to comprehend than last week's or the last exam.
Yeah, the last one was hard too.
Yeah, the last one was super hard, and it kind of piggybacks like the Venn diagrams. Like I see why we had to learn the Venn diagram first, and all of those formulas, and then going into the probability. I'm like, okay, I see what you guys did there. It makes sense. Anyway,
yeah.
Thank you, Professor, for this review.
You're welcome.
Yes, thank you.
You're welcome. I'm glad you guys had time to chat like this too. That's good. You don't get time like this. So good.
Thank you, Professor.
Thank you,
You're
Professor. Good
welcome.
night.
Good night.
Good night.
Good night.
Okay.